Okay, are you able to see my screen? Okay, yesterday we have done the ARDL test. So whenever we started with the ARDL test, we have done the first part that we have to make it stationarity, that we have to check the stationarity, which is just the eligibility criteria, that whether my data is whatever variables I am taking, that is stationary or not. Right. And after that, the next step, what we have done, we have checked the lag values. And after that, we create the model. So we just did the three steps. And now today we have to go further. We have to check the ARDL bond test. And then we have to go with the error correction term and then all the diagnostic check that we have to do it. But right now I'm doing the same part. That means whatever we have done in ARDL model, we are starting with the same part with the Enger-Granger model. Okay, so let's move with Enger-Granger model first, and then we will be doing again with the ARDL model. Okay, so that means there is no questions for that. Any doubt in co-integration? Why co-integration is done? Why we are going to check only stationarity and non-stationarity? Any doubt related to that? Okay. Now, one thing, the most special thing that you are getting confused over there, that whether we can work on non-stationary data, because we have learned till now that your time series always work on stationarity. So now this Granger, he said that why we have to convert everything into stationarity? Why can't we work on non-stationarity data? That means he said that we can work on non-stationarity data, and whenever we are working on non-stationarity data, he said that we can create a relationship between two or more variables. So first thing, when this William Granger, he said that can create a relationship between two variables, because relationship is never with one variable. It will always be minimum of two variables. So what he said, that yes, we can create a relationship with a non-stationary series only. We don't have to convert the series into stationarity. But again, there is some conditions that he put over there, that if these conditions are fulfilled, we can go with the non-stationarity data. We don't have to convert it to stationarity. But yes, beforehand, we have to check the prerequisite whether we can work for non-stationarity or not. So our first thing we are going to learn it about the Enger-Granger model. And Enger-Granger model is a two variable model. That means I won't be doing more than two variables right now with the Enger-Granger. We will start with the two variables, variable X and variable Y. One will be, you can say, your dependent variable, and another will be your independent variable. And we are saying that whether
No.
these two are having any relationship among themselves or not.
Ma'am, we are
Okay.
not doing the bond test of ARDL and all.
No, no, we will be doing. Let me first complete this part and then we are going with the ARDL, because yesterday
Okay.
I did ARDL with two variables. I did ARDL with more than two variables. Now
Okay.
we have to do ARDL bond test, AECT model. So I have to complete both the things. So first of all, I thought that first of all, let's move towards this co-integration part for Enger-Granger, because it is a two-way model only. Only two variables will be there, and then I'll again switch off to the ARDL model. Okay, so the first thing, whenever we are saying co-integration means co-moving, co-trending. That means two variables are moving together and they are having the same trend among themselves. Two variables are moving together. You just have to remember that two variables are moving together. So what we learned yesterday, when I was teaching you about this three types of things, that first thing was that whenever we are taking all the variables are stationary at levels. Okay, just the criteria to check which model of co-integration we have to apply. If your all the variables are integrated at first difference, we are going to apply the Granger and your Johansson co-integration model. And if you are getting that some variables are integrated at level and some are integrated at first difference, we are going to apply ARDL model. So that's why it's saying that if two time series are integrated, that means stationary at same level, and if their linear combination is stationary, then we can say two series are co-integrated. Now, since Enger-Granger is a model where only two variables we have to say, that's why it's written two time series. We are taking two individual time series and we are saying they are integrated at same level, that we have learned that they are integrated at first difference. If you are finding that both the time series are integrated at first difference and same level, that means x is also integrated at first difference and y is also integrated as first difference, and their linear combination is stationary. What do you mean by linear combination is stationary? Anyone having any idea what is linear combination? Linear combination means that their error term, that means your et should be stationary at level. So et should be stationary at level. So I can say et is equals to I0. If you are getting such kind of results, then we can say that your both the time series are stationary. So what you have to remember that whenever we are doing co-integration, in case of Enger-Granger model, they are based on your residuals. You just have to first of all create a model and then check the residuals, whether the residuals are integrated at level or not. And if you are getting your error term or your residuals are integrated at level, we can say that your two time series are stationary, or they are two time series are co-integrated. If it is not stationary at level, we will say that the two time series are not co-integrated. Now, anyone having any idea why I'm saying that error term should be equals to zero? It should be integrated stationary at zero. Stationary at why?
Hello.
Any hello? Yes.
Ma'am, the error term must have zero mean. Is it because of that?
No, no, it is zero mean. But why this condition is that, see, error term is zero mean, we have done regression. So whatever, this co-integration is also regression. So we are going to check all those things, that error term should be zero mean. It should be normal. It should have no autocorrelation should be there. We are going to check everything in each and every model. You have to check everything. So that is a different thing. I am saying why they have done this condition, that it should be a linear combination. Anyone having any idea about it? So what we have to do in this Enger-Granger, we just have to see two different points, that both the time series should be integrated at same level and linear combination should be stationary at I0. That means residuals should be at I0. So why? Okay, let me teach you about that also. So first thing, that what we are saying, that it means how many times is to be different, so that we are going to make it stationary. And I think now everyone is clear about it, that if I am saying that they both should do, both the time series should be stationary at first difference, so that means I have to difference it once. Maybe a log difference, maybe a simple difference. I have to do it once only, and if it becomes stationary, then I can apply this Enger-Granger model. And everyone knows this also. If we are integrating two times, we name it as I2. If we are integrating three times, we name it as I3. But we can't work on I3. Now, the time series YT is integrated order of ID if it can make stationary difference D times. That everyone knows it. That how many times you are going to difference, they will make it that time of stationarity. Now, see over here. Now, what we say that we have two time series yt and xt, right? And what we are going to do, if we are going to subtract these two things, if both are at I0, suppose I say that both are stationarity at level. So if I subtract these two, then it will become 0. It's understood. If both are at level, we are going to subtract it, it will become 0. But if both are I1, and if I'm going to subtract these two, it will come out to be I1 only. But in some special cases, this should be I0, and that special case is known as co-integration. Generally, you will never find. In normal data, you will never find that if you are taking two time series and they are integrated at first difference, so their linear model will also be integrated at first difference. But in the special case, only in the special case, I0, you will get that your yt minus dxt will be I0. And if you will find this case, it will be known as your co-integration. And we have to study this special case only. Now, uh, before this, let me tell you a simple thing why I'm saying it should be I0. You are seeing this diagram. These are the two different time series, and you will see that they are normally parallel to each other, right? They are parallel to each other, and whatever the trend is there, this is your trend, and trend is common in both the cases. If it is decreasing, second is also decreasing. If this is increasing, second is also increasing. So they are moving together. They are co-moving, and the trend is same. So what I am going to say that if from these two time series data, I am going to remove the trend. I am going to subtract these two time series. So what I am left with? I am left with trend only. Time series is removed. Only trend is left. So that's why we named it as your I0. If you are going to, if I have some time, I'll show it mathematically how if we are subtracting these two time series, how it comes out to be 0. So what are the different properties of co-integration says that they have common trend. In both the cases, if you will observe, they have a common trend. The series may be represented as one having moving average. Moving average means your error term. And the second thing that we have to remember that whenever there is a long-term relationship, whenever you will find there is a common trend, there will be the disequilibrium at any point of time. There can be disequilibrium at any point of time, and that disequilibrium can be corrected with the help of error correction model. Got this thing? Error correction model. Now, let me give you one more example over here about the error correction model. Suppose we have find that we are, I gave you this example before also. Uh, there are certain relationships which are having a long-term relationship. For example, if I say that two people are walking in a park and they have some fight, right? If they have some fight in a park, so what they are going to do? If they want, they if let's say they both are brother and sister, and if they are brother and sister, so whatever fight they are having, they are going to resolve it. So that means they are having a long-term relationship. Brother and sister are having a long-term relationship, so they are going to resolve it. There is no long-term relationship where the fights are not there. So that means whenever there is a fight, any one of the person is deviating from their duties. So they are moving together. Certainly they have a fight. So one is going straight and another is going in a left or right direction. So they are deviating from the direction in which they are moving. So what happens? Two time series are moving together and certainly a point happens where they deviate. And after that, one of the time series realizes that I am deviating, or the another time series realizes that the other is deviating. I should also move with him also only. So he also deviated. Or the first one always correct his direction. If two people are moving together, they are moving in a right straight direction, but certainly one person deviates and it moves towards the left. And after that, he realizes his mistake. He always corrects it and again he turns to the right and go in the same direction as his sister is moving. So that means whenever there is a long-term relationship, there will be the deviation in between. And whenever we are correcting that deviation, that is known as error correction model. Okay, let me give you one more example in this. How many of you are aware about monetary and fiscal policies? What are monetary policies and what are fiscal policies? Anyone from economics background?
Now, monetary policy involves central bank influencing the policies, and fiscal policy involves government.
Okay, now let's understand with the help of this economics only. Uh, let's say I'm taking two examples for interest rate and inflation, right? These are the two variables. I have to see whether interest rate and inflation moves together or not. And if you will observe that inflation rate and interest rate always move together. Let me take one example over here. Let's say housing prices. If I say that the price of houses are increasing, why the prices are increasing? Why the prices are increasing? Housing prices are increasing day by day. But you will find some time when the houses prices are not increasing. What we say? If housing prices are increasing, we say there is an inflation. Everything is the prices are increasing, there is an inflation. And why the inflation happens? Inflation happens because the people are having the more amount of disposable money in their hands. If people are having disposable money in their hands, they are going to spend it. And if they are going to spend it, it's obvious that the commodity will become expensive and we name it as the inflation is there. Now, think another way. Suppose people are not having the money in their hand and they are not purchasing the house. But they thought that in the market the interest rate are less. Let's borrow the money from the bank, and interest rate is less. And with that money, we are going to purchase the house. These days, you are saying you are able to view that every person is taking a house loan. There will be very few people who are giving the 100% down payment and they are purchasing their house from their own money. Everyone is going for the house loan. So that means interest rate was low. So that's why people are purchasing the house by way of loan and they are purchasing the house, so inflation rate increases. So what happens? Inflation and interest rate were moving together. Inflation rate was also less. Interest rate was also less. They are moving together. But certainly people says that interest rate we should purchase the house with the help of low interest rate from the bank. We should borrow it from the bank and they purchase the house. So what happens? Inflation increases due to low interest rate. So there is a deviation in both the time series. So we can say there is a disequilibrium in both the time series because the people are thinking that we should purchase at less interest rate and we should purchase the homes, and due to which your inflation increases. There is a deviation in that. Disequilibrium is that. Now government comes into intervention. What the government does? Government says that people are purchasing house, the inflation is increasing. So let's increase the interest rate. So what the government does? Government increases the house loan interest rate. Now house loan interest rate is increased. Now what the people are thinking that interest rate is increased. So let's not purchase the house at this moment. We are going to purchase the house in the near future when the interest rate will decrease. Because there is a fluctuations in the interest rate by the central bank. So whenever the fluctuations are there, interest rate increases, the purchasing power decreases. Because if more interest rate, people have to give more EMI. If they are not having this much of salary or this much of income, they are not able to pay the EMI. So what they are doing, they're postponing their investment in the house. If they are not purchasing the house at that particular moment, the house are being sold in a less number. If houses are being sold in a less number, what will happen? The inflation will go down. So what does it do? Previously, your interest rate and your inflation were moving together. People intervene and they deviate. Both the things deviate. Due to less interest rate, inflation increases. Inflation is deviating. Now, what is happening? Government is intervening. Government is also increasing the inflation rate. So, if interest rate is also increased, inflation is also increased, again they move together. So, government takes the corrective measure. So, that is known as if two time series are moving together. So, once we find out that there is a common trend, these two time series are co-integrated, they are having a long-term relationship, then only we can say that in long-term relationship, there will be some point for a short-term duration that there will be a disequilibrium. Two time series, either of the two time series will deviate from its equilibrium. And if they are deviating from their equilibrium, some corrective measures are to be taken. And that corrective measure is known as your error correction model. And whenever deviations are there, I gave you this example for interest and your inflation. And this deviation, government has to correct it within a short duration of time. Or if I give you the example for your brother and sister, if they have a fight, they have to correct it within a shorter duration of time. If suppose in the same example, instead of brother and sister, there will be boyfriend and girlfriend, and they are having a fight, and they are not going to correct it, it means their relationship is break. Their relationship is broken, and now in future they are not having any relationship. And if they are not having any relationship, there is no co-integration. So if you have to maintain your relationship for the future, one person will be the dominating person and another person will be a compromising person. And the person who is compromising, he has to move himself in the opposite direction. Let's say I and you are friends. We are the best friends. We are moving together, but somehow in some point, I says that no, I will move right. You says that no, you will move left. Let's say we are having a trip. We have to organize one trip, and we are saying that I'll move towards the right. I have to explore the. Let's say I am saying I have to explore North India, but you are saying no, I don't have to explore North India. I have to explore towards the East India. So we are deviating from each other. We are having different minds. So what will happen if we are not? That means if either I am a dominating or you are dominating, one has to compromise it with the other. If neither of us will compromise, our friendship will be broken. So one will compromise. If I am compromising, I am saying that I will move towards the north, and you are saying you will towards the east. So what I have to? I have to divert myself again towards the east. That means I was moving towards the north. I have to come back. I have to come in the opposite direction, and I have to move in the same direction as you are saying if I have to maintain my friendship. So whenever I am debating, so I will be the compromising person, and you will be the dominating person. So similarly, in time series also, there will be the error whenever there is a long-term relationship. And that error will be your error correction model. And always remember, this error correction model is always for the short-term duration. And we are going to correct it. And what I said that if I am moving towards the east, no, I am moving towards the north, and you are saying you will move towards the east. So I will come back from the north to you, and then we will move together towards the east. If I am coming back, that means I am taking the opposite direction. If I am moving towards a positive direction, I have to move towards a negative direction. So always remember, your error correction model will always be negative. It will always be negative. It will never be positive. Because error correction model, who will correct the error? Who is a compromising person? The compromising person has to move towards the opposite direction. That means in the direction in which the dominating person is moving. So it will always be negative. So in the results also, whenever we will doing, we will find that your error correction term will always be a negative sign. If negative sign is there, so that means there is a error correction term. We are again moving towards the another time series, and again there will be a time when again both the time series will move together. And it will also tell you that in how much time period the a person will deviate, or that means how much in the time period the correction will be done. If interest rate is less and inflation is more, it will take, I think, 2 months, 3 months, or 5 months, so that both the interest rate and inflation will again move together. So it will tell you the time period also. What will be the time period and what will be the speed? At what speed your correction will be done? So now, any doubt in theory? Any doubt? No doubt? So what we have learned that there will be a common trend, as we have learned that common trend is there. Your x is moving upward, y is moving upward, and there will be a common trend in both the things. So that means we can name it as they are collinear. So if they are having a common trend, we will name it as a co-integrated. You can also judge it by way of diagram also. Or this is one of the way to represent whether the two variables are co-integrated or not. Or another way we can say that there must be a linear combination such that trend cancels out and only the stationary terms survive. That's why we name it as I0. If I'm subtracting one minus first series minus second series, that means trend is obviously decreased. If I'm saying 1 plus 1 is 2 and another 1 plus 1 is 2, another is also 1 is a trend. I'm saying 2 plus 1 is 3. So if I'm subtracting 3 minus 2, the remaining part remain is 1. 1 means your base from where the time series you have started. So we name it as I0. Now, any doubt in this? No doubt. This we have done. Your ET should always be I0. Now see over here in this diagram also, you will see that there is a common trend. Your trend is common. In all the cases, trend is common, but I am not saying 100% time this trend is common. There will be some time period when it will deviate. Over here, suppose you are saying the gap over here, they are moving parallel, but there will be some time period they are not parallel. Suppose over here it moves like this, and again it starts moving parallel. So this is a time period where the error correction model is required. So let's start. So I am starting with the first thing. Okay, now. Now I have given you one data of export and import. Now everyone is having the data for export and import.
Yes, ma'am.
Okay. So first of all, we will do with the data and then I'll start with the R. Angel Granger is better in stata. You are not able to understand as much clear as in R as much you can understand with the stata. Now, for doing the Angel Granger model, there are two different ways. The first way is that, first of all, I'll make a regression equation. That means one dependent and one independent. You can take anything as a dependent and any as an independent because we are just learning whether they are co-integrated or not. That means I can put, if I have given you time series data for export and import, you can take export as dependent, import as independent, or import as dependent and export as independent. You can do anything, but the only thing is that both the variables should be of same order. And now, till now, you have understood that Engel-Granger model is a residual model. We just have to check the residuals. That means, first of all, I'll create a model and then I'll check the residuals. And if the residuals are stationary, that means I don't have to convert the residuals for first difference to check it stationary. If it is already stationary, or in other words, I can say that if the mean is 0, I can say that the two variables are co-integrated. So this is one of the methods. And another method is what I can do, I can directly put the formula of Engel and Granger and it will directly give me the results. So we will be doing by both the methods. And one thing more, for checking the stationary till now, what we have learned that we will check for Dickey-Fuller test. Philip parent test or KPSS test, right? We have done this thing to check the stationary. We use these methods, but over here, we are not going to check the stationarity of variables. Over here, I am saying that the two series are co-integrated when their error term is stationary at level. And if you will see that error term is not observable. Error terms are those terms which we cannot see. We have not observed. There can be n number of error terms. If it can be observed, we must have taken as an independent variable. So error terms is not observable. So we cannot check it by simple p-value. That means by simple augmented Dickey-Fuller statistics. If you remember, while doing ADF test, I taught you two things. We can check it by p-value also. We can check by ADF statistics also. But in co-integration, since we are checking the stationarity of residuals, you can check by p-value, but you cannot check by ADF test. That will not be validate. We will be doing ADF, but whatever ADF value will be there, statistics will be there, ADF statistics. We cannot check with that ADF statistics whether our data is residuals are stationary or not. For that, we have to check the table value. You have to remember this thing. We have to check the table value. Whatever statistics we'll be getting by the software, never go with that statistics. And the reason is residuals are not observable. We cannot observe it. But we can observe the variables, normal variables. Suppose I'm checking the stationarity of export, I'm checking the stationarity of import. I can observe all the values. So that's why over there we are using ADF test, and we can use either p value or your ADF value. Okay. So once we check that my data is stationary, after that, if data is stationary, it means there is a long-term relationship. So what we are going to check? We are going to check the error correction model. And as I told you, error correction model is always a short term. Once you have checked your ECT, we will do the model diagnostic. That means all the assumptions that we are doing in the residual case for regression, it is also a regression. We will check all the diagnostics. And so let me start with the first method first. Now, I have given you one data set. You can check it. Exports are there and imports are there. And if you will observe that data set, I think I have given you the monthly data starting from 1961 till month 4 of 2020. That means January 1961 till month 4 of 2020, or I think I have given you something else. I think I have given you from 2015 onwards, right? I have given you from 1961 or 2015. Okay, I don't remember which data I have provided to you. If it is 1961 month 1 or maybe 2015 month 1, so whatever is that, you can write it over there. And till the last date of the month that I have given you, we are going to check it. So first thing, we are going to check the stationarity. And again, we will estimate the long-term model. And if you will see, it is just a regression model that I have created. And after that, I'm going to calculate the residuals, or I can say I will save all the residuals. And then I will check the ADF test. I will check the stationarity of residuals. And if the stationarity is, that means if the stationarity is less than that, p value is less than 0.05, or whether the table value is more than the value given by ADF, we find it. So we can say that your residuals are stationary and your all the two time series are co-integrated. And if we are not going to get these values, your p value is more than 0.05, or the ADF value is less than the table value, we will name it as your both the time series are not co-integrated. And if they are not co-integrated, that means we are not going to calculate the error correction model. Till here clear? Any doubt till here? So should we move to Stata?
Yes, ma'am.
Okay, so let's start with the Stata. So first thing what they are saying, okay, Now data is there. First of all, import your file. Yes, now you are going to tell me what I have to write it over here. First thing, what should I do? Till now, I think you are able to operate data.
T set date.
T set date. The full form of T set is I am giving the instruction to R that this is the data I am giving to you is a time series data and it is depending on date. So is the command correct? Is the command correct?
Yes, ma'am.
No. See, it will say the date variable is not found. You are saying that set the time series. The command is I am saying to data that I am giving you time series data and you have to arrange that time series with respect to date. But over here, if you will observe, I have not given the name date in the data. I have given the month. I have given the variable name month. This is a software. It will not understand the word date. It will understand only those words which I have given. If I mention the name month, so it will understand the month. Okay. Now let me write TS set month. Now see, it has taken it. So my data is starting from uh, 2015, April 2015. This is 1st April 2015 till 1st July 2022. But what is the mistake over here? It has taken, this is a time series data, it has understood. But what is the mistake over here? If you can tell me. If anyone can observe, because after the workshop, you have to observe your data or R on your own. Otherwise, you will be stuck. From the very first step, you are able to know whether whatever command we are running, maybe in Stata, maybe in eViews, maybe in R, they are correct or not. Now, I'll tell you. Over here, you are saying it's written one day. Here you can write but with gap and delta is one day. That means it has given me that the data I am giving to Stata is a daily data, one day data, daily data. But if you will observe over here, this is my sheet. This is monthly data. 1st April 2015, 1st May 2015, 1st June 2015. It is not a daily data, it is a monthly data. So that means I have to instruct R that I have given you time series data, but that is not a daily data, it is a monthly data. Got my point? Are you able to see over here also it is written 1st April 2015. If I'll see over here 1st May 2015, this is a monthly data. But Stata has not understood it. It has, and for Stata, your time series means daily. If you are taking yearly data, quarterly data, you have to tell Stata that I am giving you quarterly data, I am giving you yearly data, but because by default it will understand the daily data. Got it? Should we start? Now, what I am going to give the command to Stata that this is a monthly data. So I'll say generate. I am generating one more variable. And you can generate with any name. So I can say date one. Generate date one is equals to, I am saying I am giving you TM. If you are not taking the monthly data, you are taking quarterly data, give TQ. If you are taking yearly data, TY. And after that, you will say that my monthly data starts from 2015 and the month is April. Got it? So I am instructing R or this data that I am giving you monthly data and it is starting from the month of April. And after that, it's not only 1 month, it's starting from April and it will end till n minus 1. So you have to take till all the series. Now you will observe over here, just observe over here, it has created you the date column. But I cannot read these dates. Data can read it, but I cannot read it. 663, 664, if I write 677, 678, you will not be able to understand that what does 676, 678 mean. So now what I'll do, I'll give the names to it. So I'll write format, do the formatting. I'm not able to understand your dialogue. Do the formatting of date 1 and just write percentage TM. Just convert it into the monthly form. Format. Okay, now let's see over here. Now can you read it? 2015 month 4, 2015 month 5, 2015 month 6. It's one and the same thing, isn't it? Got it? How to convert the date column? How to instruct this data that I am giving you this type of data? So now you can convert it in quarterly also. If you are giving the quarterly, you can convert it into yearly also. Now, first thing that we have learned, we will always make a graph and see whether my data is co-integrated or not. With the graph, I can just observe if trend is common, my data is co-integrated. And the command is TS line, time series line. And your first variable is exports. And your second variable is imports. Now, can you tell me whether these data are co-integrated or not? There is a long-term relationship or not? Yes, can you observe the long-term relationship?
Yes, ma'am.
Yes, see, they are trending. Over here also, if one is moving down, another is also moving down, but there are some deviations. You will see that the gap among these two lines are increasing and decreasing. So some deviations are there, but somehow they will take the error correction term and the deviation will be over. So what is the next step? My next step is to check which kind of model I have to create, whether I have to create the Johansson model, whether I have to create the Enger-Granger model, whether I have to create the ARDL model. And for that, I am going to check the stationarity. And for stationarity, we will check by ADF. So D Fuller and name of the first variable export. Wait. It's saying solution. Okay, fine. So now what they are saying, since we have, whenever you will find anything in data like that, always try to convert the data into log terms. So let us generate in log. So I'm giving the variable name lx equals to log, otherwise it will not be able to recognize it. So I have generated one of the variable. I have taken log of exports. I named it as lx. And now I'm going to create log of imports, log lm. And I think everyone is aware that x is always denoted for exports and m is for imports. Log imports. Now, see over here, your lx and lm are created. Your LX is created, your LM is created. Now I have not taken difference, I have not converted it. I have just taken a simple log. Now let us check the stationarity. So D Fuller and your LX. Some problem is you just try whether you are also getting or not. Just check yours. Let me check my do file also. Some problem is there. Are you getting it or not? Any one of you got the answer for D Fuller or not? Yes, anyone got it or not? Because over here I'm not able to get it.
Doing it, ma'am.
No, ma'am.
You are also not able to get it. I think some problem is there. Because it's again and again saying no observation. This is created. Oh, see, what I have done, I have created, but I have forgot to give the instruction to R that from now onwards, T said date 1. I forgot to do it. Now it has learned that my series is monthly. See, this is a mistake that I have done. We have converted into monthly data, but we forgot to give the instruction to data. Now just give the instruction TS said date 1. Now it will say delta 1 month. Now previously, if you will observe what it was saying, day 1. Now it's saying month 1. Now Stata has understood my data is monthly data. Now if you are going to find D Fuller LX, it will give you the answer. So we have to learn from our mistakes, what mistake we have done it. Now, if you will see the p-value is more than 5%. So that means export is not stationary at level. Now let's check for LM also. Now, if you will check for LM, its p-value is also more than 0.05. So your LM is not stationary at level. Now, what we are going to do, we are going to take, now just tell me this is a price data. Now I have to take a log difference or simple difference. Yes. What I have to take, a log difference or a simple difference?
Log difference.
No, I am going to take a simple difference because I have already converted into log. So if you are going to convert, suppose if you are working on a price data and you have converted into log series. So whenever you have to convert it into stationary, you will take a difference only. In R, if you remember what we did, your log. First of all, I'll write difference of log series. This is my command diff log n225. So what we are doing? First of all, in BODMAS tool, we are going to solve the bracket. So first of all, we will take log, and whatever log we have taken, then we are going to take the difference of that. So in this data right now, I have already taken the log. So just to convert it into stationary, I don't have to take log again. I will take a simple difference. And in this, for simple difference, it's an inbuilt command. I can directly check d fuller and difference. If I write d dot lx, it will automatically convert into difference. Now you will see that your p value is 0.00. So that means your exports, LX means exports are stationary at first difference. And again, if I am going to check D fuller, D dot LM, so your imports are also stationary at first difference. So what we have learned that both export and imports are stationary at first difference. And this is a bivariate model. So Enger-Granger will be there. We cannot apply ARDL in this. We will apply Enger-Granger model. Got this thing? Any doubt in this? Everyone got this till here? Now, we have learned in your Enger-Granger part, we have done this thing. So we got this thing, we have converted. Now see over here. Whenever we are checking the stationarity for your log x and log m, both the variables are non-stationary. So what we did, we just converted into stationary, and we came to know that my model is, we have to apply the Enger-Granger co-integration model. And the third step, next step is that we have to regress it. So what we are going to do, we have to regress, we have to make a regression. Now regression model, let's do it with the regression. So my command will be regress your first variable, your exports. Do remember we are not giving we are not giving your difference variable, that means stationarity. We will give the original series, that means your LX and your LM. Now these are your results. That means if 1% increase in imports, 1% increase in imports will lead to 0.83 of imports. Your exports will increase by 0.836 percentage of your imports. Now, what is the next step? Your co-integration model is based on residuals. So we have to create a residuals for this. And then we are going to check the residuals. So let's save it. So I'll write predict the residuals. So you can give any name. Let me give the name error. And I am saying that in the error term, just save the residuals. Now, if you will observe over here, your error term is created. See, your error term is created and all the residuals are stored in it. Now we have to check the residuals. So what we are going to do, first of all, we will calculate its summary. That means its mean, median. So I can write some error. Now you can observe over here, the summary means your descriptive statistics of the error term. Your number of observations are 88. Your mean is 5.95 E minus 11. E minus 11 means we have to shift 11 digits, decimals to be 11 digits left hand side, and which will be 0.10 zeros and 5.95. So it's near about to 0. So my error term is 0, which is indicating that my data is these two variables, exports and imports, are co-integrated. Now let's check the other part also. So let me check, we should make a line. Stationarity says that all the values should fall on the 0. It should be constant. So let's make a line. TF line of what? We want to make the TF line of error term. And now if I'm going to make a TS line and I'm just saying that draw a line also, Y line, so that I'm able to know that all the variables are lying on 0 or not. So Y line with this mean. So our motive is that mean should be 0. Now you can see that it has make the line of the mean and which is coming on 0. So that means which is showing that my data is co-integrated. Now, for the stationarity, we have also learned that we have to apply the ADF test. So again, defuller and your error. But whenever we are applying defuller, we don't need the constant term as we have done in the regression. So I'll write no constant. Now, you will get the answer for Dickey-Fuller test. But what the question arises, over here you will not find any p-value. So how can I judge whether my error term is stationary or not? There are 3 tests only, ADF test, PP test, and your KPSS test. But p-value is not there. Otherwise, by seeing the p-value, I can judge whether my data is stationary or not. So what we'll do, we will check with this test statistics. And we will not check this test statistics with by minus 0.05 or anything else. We will see the table value. And for that table value, I'll just show you the table. This is the table. So we have to check the co-integration test table. And over here, if you remember, we have the 88 observation. If you will see number of observations over there is 88. You can see 88 observations are there. So that means what I have to do from the table value, I have to see with the 88 observation. This is a sample size. If 50 sample size is there at 5% level, the answer should be 3.67. If 100 observations are there, your answer should be 3.37. If 200 are there, answer should be 3.37. But in our case, we have only 88 observations, so we fall under this category. So my values should be more than 3.37. So if my values are more than 3.37, you will observe that your values, let's see our values. Our value is minus 5.9, minus 5.797. Minus 5.797 comes towards the left of 3.37, which is my table value. So that means it is coming under a rejection area. Value, whatever value we are getting, it is under the rejection area. So we are going to reject our null hypothesis. So null hypothesis says that the data is not stationary and alternative says that data is stationary. So that means my error term is stationary. So we have proved that since my error term is stationary, so both the series are co-integrated. Now, any doubt in this? This is the first method that we are going to, we have done it. This was my first method. So exports and imports are co-integrated to each other. Now I am moving to the second method. So now what I'll do, I'll directly apply the Granger command. So in your system, I think Granger is not installed because you have to install it. So you can directly write SSC install Granger. Just write this command. SSC install Granger. Your Stata will install it automatically. So since it is already there, so that's why it's written all files already exist and it is up to date now. So if it is not there, it has already installed it, but my system has already this Granger. So once you install it, you can directly write the command Granger and your original CD is LX and LX. Now you will get the same values. If you can see over here, previously I have done a long method. I first created the regression. Then what I did, then I converted the residuals and then I checked the ADF of residuals. But now I have directly applied the Granger model and the same results are there. Minus 5.797 was the test statistics and right now also minus 5.797 is my test statistic. So that means my both the things are co-integrated. Any doubt till here? Now what we have to do? Now what is the next step?
ECM.
ECM. And always remember ECM never works on original data. Since my data is co-integrated, so there will be some error correction term. Error correction term, we are going to calculate it. Error correction term is a short-term term. So in a short term, disequilibrium is there. Both the series are deviating, so they have to come back, and I have to check the error correction term ECT, and it will always work on stationary data. Granger, ARDL, Johansson co-integration, they all work on non-stationary data. But error correction term works on stationary data. It will never work on non-stationary data. Got this thing? So first of all, I'll again make a model regress and regress of the stationarity data. Stationarity data, I told you that this data has a inbuilt software. So d.lx, d.lm, and I have to take the lag values of error term. So it has the inbuilt, so lag value, whenever you have to take the lag value in this data, you just have to write L dot error. Now you can see over here. Are you able to observe this thing? Okay, let me give you the PPT and then you will be observing. Now, are you able to see this? Now, see what this you have done. Okay, if you are going to move towards the theory part, so this is my error correction term. So now what you have observed over there, in this your p-value is less than 0.05. If you will see over here also, see your lm has a p-value less than 0.05. Your error term is also having a p-value less than 0.05. Both are significant. But I want to show you one more thing over here. Now, if you will see this term, previously, this is my previous regression that I have applied for LX and LM. Let me show you over here also. This is my current term. Just remember LM is 1.01. Your error term is minus 1.59. Just remember these two terms. LM is 1.01 and over here error term is minus 1.59. But let's move to the previous over here. Your LM term is 0.836. Are you seeing? Here the LM term is 0.836 and here your LM term is 1.01. So it is showing you that there is a discrepancy. It is disequilibrium is there, discrepancy is there. And that's what I want to show it in the PPT, that over here it's minus 8.36 when I originally regressed it, and now it is 1.81. Discrepancy is there in a long run and short term. This is my error correction model. Error correction model is a short term model. Your co-integration is a long term model, and there is a discrepancy. So what is it telling? That exports are increased by slower pattern, so it is to be fixed by ECT. If I am going to observe that diagram, exports are moving slowly and imports are moving quickly. So there is a discrepancy. What we learned, trend should be same. So there is a discrepancy and this can be fixed by error correction term. And if you will observe the error correction term, if you will see the error term, it is a negative. I told you your error correction term will be negative. It is minus 0.594. So see over here. This is your ECT coefficient, minus 5.918. This is your error correction. Any doubt in here? And I have already told you ECT should be negative. It should not be positive, because this is the compromising term. It is deviating. It is coming back. It somehow move further, but it is again moving back. Back means opposite direction. Opposite direction means your negative term. Now, next last part, what is left is diagnostic check. So what we have to do again? I have to do the diagnostic check. Again, you have diagnostic check are always related to your residuals. All the assumptions are related to your residuals. So what I have to do? Again, I have to predict the residuals. Previously, I have already given the term error. So I cannot give the same name again. So let me give the name residuals. So I'm saying residuals, create residuals. So now what it'll do, it will create your one new term as residuals. Now see, it has created one new term as your residuals. Now the same thing, we are going to check it. So first of all, let me check the TS line of the TS line residuals. Now I have not given the command Y line. Otherwise, if I have given the command Y line, your mean is 0 over here. Or even I can just check for the mean residuals. You can check your mean is minus 2.07 E 10, which is near about 0. Got it? Now next check is for normality, and for normality we have Shapiro-Wilk test. So I'll say S Wilk and then residuals. Now Shapiro-Wilk test, you can see the p-value is less than 0.01. So you can say whether it's a normal or not. What is the hypothesis for this? What is the hypothesis for normality? We have different tests. Jarki-Miller test is for the normality. What is the hypothesis? Null hypothesis says that data is normal. Alternative says data is not normal. So in time series, we hardly get the normal data. And last is you have to check the autocorrelation, or you can say serial correlation. And for that, we have White test. So you can say the command WNTSTQ and then residuals. And again, your serial correlation, for that, your command is there is no correlation is your null hypothesis, and the alternative is says there is correlation. And you will say that p-value is more than 0.05. So we will go with your null hypothesis, which means the data is not correlated, or error terms are not correlated. So are all the terms and conditions, including your diagnostic check, are fulfilled? So I can say that your exports and imports are co-integrated. So we have done this. See, I have made this PPT for you so that for each and every step you are able to understand how we are going to do it. I have written each and everything. For step 17, you have to do this thing. This will be your observation. I have given you the data that whenever you are checking with the data at any point of time, you will not face any difficulty. So this is your observation. Residuals are 0. And after that, you are going to apply the Shapiro-Wilk test. For normality, I have given you the null hypothesis. Your null hypothesis is this, which is less than 0.05. Next, we have to check for serial correlation, and your p-value is more than 0.05. Hence, we are going with the null hypothesis. So any doubt till here? No doubt?
No, ma'am.
Okay, now let's do the same thing with R. Now I don't have to explain anything to you about it. Just export your file. Okay, let me attach the file. Attach your file name is export import. Now let me library T series. Now let us check the ADF. So ADF.test, your exports. It is not stationary. So let us take, we have to take the log difference. So your log difference will be, let's say R export equals to diff log exports. And if I'm going to check it, ADF.test R exports, see it has become stationary. So similarly, you can check for imports also. Imports will also become stationary at first difference. Now we will be requiring two packages for Engine Granger model. So just library and your first package is Urka. Now just install this package Urka. Just install this package Urka. Done.
Ma'am.
Now second package that we will be requiring is Engine Granger co-integration model. So second is library Engine E Granger G co-integration C and M for model. EGCM model, Engine Granger co-integrating model. Done. Now command is very simple. Just store the command in any variable. I think I have not taken. Oh, okay. I have not taken X, so I'm just storing in X. You can store in any variable. EGCM Engine Granger co-integration model and write the name of both the variables. Exports, comma, imports. And then summary X.
Ma'am, R exports or this
No,
export?
exports, original series. I told you that your Engine Granger and your Johansson and ARDL works on original series, but error correction term works on your stationary series. So whenever we will be calculating the error correction term, we cannot work on export and import. In that case, I have to use R exports, R imports.
Okay, that is for ECM.
Yeah, that is for ECM. But just to check whether there is a co-integration or not, we will work on original series. And you are aware that in this Engine Granger, we have to check the unit root of residuals. We have to check whether the residuals are stationary or not. If residuals comes out to be stationary at level, it means my both the series are co-integrated. And this R, you have seen by Stata that what are the different steps, but in R, you can directly do it. you can see that it has already calculated the unit root of residuals. And first of all, if I'm going to check it by ADF, it has given me all the different forms by which I can check the stationarity. So ADF test, you will see the p-value is 0.07 and your Philip parent test is 0.01. And you will observe that mostly in all the cases, your p-value is less than 0.05. If your p-value is less than 0.05, it shows that residuals are stationary. If my residuals are stationary, it means my export and imports are co-integrated. Got it? Any doubt? No doubt?
No, ma'am.
Okay. Now let's move to error correction term. Before that, let me move to, because error correction term will be same for ARDL and this, both the cases where error correction term is there. So let again, now I'm going with the ARDL model. I cannot run ARDL on export and import because both are integrated at first difference. But my conditions are that ARDL model, we can apply ARDL model when the variables are having a combination of one variable should be integrated at 0 and other at 1. If export is at 0, import it as 1, or import is at 0, export is at 1, I can apply ARDL. So that means on this data, I cannot apply ARDL. So for that, again, I'm importing the data set that I have given you for Indian economic yesterday. Data Indian economic. And I have to attach the file. Name is data underscore Indian economic. And I have to library dlag n. Done. Now we are going to apply the ARDL model. We have learned how to create it. Today we will do with the ARDL bond test and we will check whether there is a co-integration or not. And if there is a co-integration, then what will be your error correction term and all the residuals check should be there. So first of all, let's create the ARDL bond test. So ARDL bond test over here, let me write you the assumptions. So let's say for ARDL bond test, your assumptions will be, your H0 will be that there is no co-integration. And your H1 will be that there is co-integration. So let's create ARDL bond. So I'm creating the ARDL bond test. Data equals to, my file name is data Indian economy. So data underscore Indian economy. I am giving the instructions to R, take the data from here, and formula is equals to your, let's say we'll do again by these two variables only. So I can say that inflation and interest rate. I'm doing it by these two, inflation and interest rate, because both are integrated at different level. We have checked it yesterday also. Comma, case 3. Now I'm going to tell you what do you mean by word case 3. And then I'm going to write max. This we have done yesterday, so I'm not calculating the lag values again. So max dot p is equals to 3 and max dot q is equals to 1. Now, what is your case 3? Now, we have here,
It should be Q.
okay, P, okay, it should be Q. Q is what? Okay, let me tell you what are the different cases. We have case 1. So, case 1 says that there should be no intercept and no trend. But we are working on the trend also. We are saying there is a trend, isn't it? In co-integration, we are saying there is a trend. So how can you say that we are not, there is no trend? Case 2 says that there is restricted intercept. But we are not we can say, because in co-integration we are saying that if I'm going to subtract these two, that means xt, or you can say yt and xt, trend will be left. So we can say that no, we are subtracting the trend, we are removing the trend. So I can work on no trend, but I cannot work on restricted data. Restricted trend should not be there. So it is saying restricted trend, restricted intercept. Restricted intercept. So restricted intercept should not be there. Restricted intercept and no trend. So I cannot work on this. Case 3 is saying your unrestricted intercept and no trend. So in financial time series, whenever we are working in finance in anything, we always work on unrestricted. Over here, case 4 is unrestricted intercept and restricted trend, and 5 is unrestricted intercept and unrestricted trend. But we normally work on case 3, that's why we are working over here. Now, what we have to check? We have to check the Pisaran test. This is my test statistic. This is my Pisaran test. I will check the Pisaran test for co-integration. Now, how you are going to check it? Now, if your this value is less than I0, if your this value, F statistics value is less than I0, I0 is what? Your 4.94. You remember right now I've shown you the table. It is not falling within, it is falling in the exterior. The value we got it minus 5.75, it is falling outside. It is greater than the value. See over here. If I'll show you this thing, see, value is greater than the whatever value we are getting for the F statistic is greater than the table value. So if it is greater, we are going to accept it. If it is smaller, we are going to reject it. It is a rejection area. It is a rejection area. So it should be greater than this. And over here also the same thing I am saying. If F statistics value is smaller than I0, in that case, we are going to accept the null hypothesis. We say that there is no co-integration. If this value is more than I1, we will say that we are going to accept H1. There is co-integration. And over here, F statistics is more than I1 at 5% level of significance. 16 is more than 5.73. So we can say that there is co-integration. There is co-integration. So now co-integration is there. So now you will see that it has given you the error correction term. Are you able to see the error correction model? And error correction term will be there. And if you will observe, each and every test are there. Your Aljung box test is there. Your
Ma'am,
Rishvegan test is
our This alternative hypothesis is there is co-integration. If f statistics is greater than I0, then we will reject the null hypothesis, right? Then it
If your F statistics is greater than I1,
I1. Okay.
if it is greater than I1, we will reject null hypothesis. We will go with alternative. But if your F statistics is less than I0, we will
Mhm.
accept null hypothesis and reject your alternative. So your
Okay.
F statistics is more than your I1, maybe at 10%, maybe at 5%, maybe at 1%. Normally we check at 5%. If it is more, we will say there is co-integration. If it is less, we will say there is no co-integration.
Okay.
And all the tests are there. Shapiro-Wilk test is there. You can check see, every test is for residuals. R will automatically give you in one shot only. There is no homoscedasticity. If you remember, the hypothesis for homoscedasticity, H0 says the homoscedasticity is there and H1 says hetero. And our answer should be homo. We are saying they are IID. So if p value is more than 0.05, so homoscedasticity is there. Your normality Shapiro-Wilk test we have just done. Shapiro-Wilk test is p value is less than 0.05. So we can say that data is not normal, and we all know that for time series my data is never normal. And for autocorrelation we have L-Jung-Box test. So my null says no autocorrelation and alternative says there is correlation, and my p value is more than 0.05. So there is no autocorrelation. Got it? And if you remember in autocorrelation, I told you two ways are there. One was for Durbin-Watson test for autocorrelation and one was Brush-Godfrey test. And we apply Durbin-Watson when one lag is there, when more than one lag, Brush-Pagan test. So everything, if you will see everything, R will give you everything over there. The autocorrelation is of order 2, that's why they have given Brush-Godfrey test. If it is for order 1, Durbin-Watson test. So you have to remember all these things. Got it? Now, any doubt? This we have done, I have done. Okay, we have done all this part. Yes, any doubt to anyone? No doubt?
No, ma'am.
So tomorrow we will be doing, we are starting